Can you see? Okay.
Yes, yes, yes.
Okay.
History of TKA.
Yes, yes, exactly. Or
Yes, I
did
see.
you or did you hear this presentation before?
Yes. No, 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 no,
No, no. Okay,
no,
this is
no.
first time.
First time for
Maybe
me.
first time. Okay, maybe Zani too. We meet out has already heard this talk. So anyway, it's very nice because you are first time. So to have this presentation with ask you how do you think about total knee? So this question is to how to regenerate or reconstruct a disrupted knee. So there are two type of the policy, the two way to think about the reconstruction. So one way is to consider the knee, the hinge joint. So and another one is to resurfacing. So this means uh, regenerate, reconstruct the function, the flexion and the extension function. So another this resurfacing means the osteoarthritis is characterized by cartilage wear on the degeneration of the joint surface. So just the resurface using the polyethylene and metal. So one way is functional approach, so we call functional approach. So regards the knee joint as the hinge. Another one to only the resurface to regenerate the new articular surface. So this is the anatomical approach. So this is the beginning of the TKA. I haven't seen these components that we see only in the paper or some the museum, TKA museum. This is the very famous hinge knee. This is only the hinge joint flexion. It can allow flexion and extension only. So in these knees, so ligament and the kinematics is completely ignored. So this is another type of the hinge knee. These are the functional approach. So these the aim of this component is to generate the hinge mount flexion and extension motion. Another approach is to an anatomical approach to resurfacing like this. Okay, this is to resurfacing using this tibial component, tibial resurfacing. Another one is the both tibia and the femur component. So this is something like bicondylar knee. But unfortunately, the result is very devastating. The very catastrophic losing can occur in these knees. This is a very historical component. This is only the tibial side. This is both tibial side and the femur side, femur component. It is a group, rail and group. It's very interesting. It's very 80s, 50s, and 60s. But the knee is very have the complex motion in combined motion of rolling and gliding and rotation. Professor is coming. Okay, this This in extension to flexion, the knee will bend the knee, can flex the knee, but in the same time, the knee will slide to each other. So because there's a contact point here in the 0 degrees and 120 degrees here, the distance from here to here is longer in the femur side than tibia side. It implies so it needs the sliding motion is needed to achieve this motion. In addition, there is no simple flexion and extension movement. So knee will rotate around the medial side. So we call it the medial pivot motion. So during the flexion, lateral condyle move posteriorly. So in contrast, medial side is relatively stable. So kinematic motion is quite complex motion. The combination of these three motions are different among the patients. So the disadvantage problem of this hinge knee is it can allow sidal motion only. No rotation and sliding motion are allowed. So and ligament function is ignored. So as a result, there are so many loosening in these components. So this is a modern hinge type knee. It can allow the rotation on the tibia trace. So after the introduction of this rotator hinge knee, this kind of knee result is improved dramatically. This the legend innovator of knee arthroplasty, Dr. Insol, Freeman, and Ranawat. They are very famous. They are legends. The first total knee is very, very interesting. This is only the simple cylinder. It can allow only the flexion and extension. Both ACL and PCL sacrificed to get a wider contact area and to correct the deformity. But to achieve the very stable motion, we call it a roller in throw design. So cylinder in the groove. Very simple kinematics. And no particular group. So this is for these knees, the gap balance is very important. So parallel and equal flexion and the extension gap is required. So this is the start of parallel and equal flexion and extension gap theory. So this is the same as the theory of insole. So otherwise, they can occur the dislocation. Okay. So this is go back to the previous slide. So the first type of anatomical approach is like this. The two components. This is something like the bicondylar unicompartment arthroplasty, just like the TKA. But result was not so good. So next version is combined to connect the medial side and the lateral side, and with this bar. And the tibia tray is not the groove shape, but flat shape. So low constraint type. In this prosthesis, ACL and PCL are preserved. So truly just like the bicondylar UKA. So anatomical and symmetric shape, and is fixed by cement, but no patella group. So sometimes patella will impinge with this bar, then that's called the anterior kidney pain. So the tibia tray is separated, so it can cause the loosening. So in addition, this tibia tray is all polyethylene. So this is followed by the more anatomical version with the duopatellar knee. It is also legend we can't use now. This is the total condylar process. This is the first worldly success prosthesis. In a long time, it was used all over the world. So only one or two cases I have seen this prosthesis in the very old patient, but I haven't seen the operation of this component. But this is the carbon curve, so it has the high conformity. So for the TKA, it is very difficult to constrain the conformity of the polyethylene and the PIMA component. If the conformity is very high, so this component can provide the good stability. But high constraint sometimes cause the limitation of the ROM and loosening. So high contact stress can cause the high stress between the prosthesis and the bone, followed by the loosening. So otherwise, low conformity. Conformity can cause the reduced the mechanical stress between the bone and the prosthesis, but sometimes it can cause instability due to the low conformity. And so low conformity prosthesis needs the ligament function. So this conformity is higher and higher than we can sacrifice the ligament. For example, ACL, PCL. So this is a symmetrical shape. And so it can also innovative because it can allow restore the flexion along with gliding motion and rotation motion. Because unlike the Freeman knee, it can rotate around this center cone. This is a double dish tibial geometry. So it can cause the body second articulation in the both medial and lateral side. So this is also the first prosthesis that have the patellar prosthesis. So we can see the groove anterior surface of the tibia component. It can articulate with the patella. The patellar surface is also replaced by the polyethylene. So sophisticated instrument set. It's very, very improved instrument set. It can also act as the successful operation. So after these processes, it is followed by some several types of prosthesis. This is the one way is cruciate preserving version. This is the kind of anatomical approach. So retain at least the PCL in some knee in the ACL, both ACL and PCL, and only the resurface the articular surface. And PCL sacrifice knee is condylar knee, and so this solution is just like this. If this conformity in adaptation is higher, so high stress will transmit to the bone and prosthesis component. So rotator, this type of prosthesis can allow the rotation, some kind of so-called rotator platform. So high stress due to the high conformity on bearing and the female component. So this stress will go to the rotation motion. So it reduces the bone and prosthesis implant interface stress. So it can reduce the loosening. And another way is post-outcome mechanism. This is just like the PS knee, in the current PS knee. So there are so many approaches to improve sub-dilemma of the conformity and the mechanical stress between the femur and the bearing and the tibial and the bone interface. So one way is only the resurfacing to keeping the ACL and the PCL. Another one is to keep the high conformity between the polyethylene and the female component, and it can allow the rotator motion between the tibial and the bearing. And third one is post and come mechanism. This is a really innovative device. So because it can induce the both posterior stabilization, posterior stability along with the load of motion due to the post and come mechanism. So this is the very famous insole Bastien total knee. It is the kind of PS knee. It has a post and come and a very high groove. So contact point is posterized. So and anterior large heel prevented anterior instability. And wide come and post. So induce this post and come mechanism induce rollback motion. So during the deep flexion. So before the 70 degrees, so the stability is contact with the post and come never occur. This stability is provided by this anterior rim. But after the 70 degrees, the post and come will hit. We call it engage. After that, this post can act as a posterior stabilizer along with the rollback induced of the femoral component. So this post and mechanism is continued and improved to our current modern prosthesis. And another approach is this is a truly resurfacing approach. It is also for the partial knee. So maybe the chant this process very well. You saw this operation so many times in my hospital. So surprisingly, this is developed in the late 70s. It's just around near the 50 years. But the concept has never changed. It's incredible. It's very long hip prosthesis. It's a similar generation in these legend knees. So we also use still use these components. So this is the unicompartment arthroplasty, fully congruent, just like the LCS. The femur and the bearing is the fully conformed, fully congruent, just like ball and socket, just like total hip, and but no constraints. So this bearing move completely passively. between the female and the female component. The great innovation is they change the shape of female component in the complete true single radius. So full in contact, full congruence can be achieved to after the change of the female component. So in our knee, the meniscus can change their shape. In the extension and flexion, the meniscus can change their thickness and width and the location. But this bearing never change their shape, but it can follow the shape of the female component. It is really innovative and surprising. So bearing moves completely passively. So all major ligaments, including ACL and PCL, can be preserved. It can improve the patient satisfaction. And extremely rare wear is very small amount, around 0.01 millimeter per year. So this is a combination of John Goodfellow and John Corner. He is a Goodfellow. She is the surgeon, orthopedic surgeon. Here, the Corner is the engineer. This generation, the many innovative components implants are developed by the combination of the engineer and the surgeon. So good collaboration. Surprisingly, Dr. O'Connor is still alive. Maybe he is late 90s. It's incredible. He is a living legend. And this is the Miller Gallant prosthesis. This is a PCA preserving anatomical approach. I used this prosthesis in the early my orthopedic career. I was a resident. This is the most popular prosthesis. This is a prosthesis. This is the anatomical shape. The minimize the bone resection and flat down the front articulation. That means the no constraint, no constraint between the prosthesis and prosthesis. So it can freely move on the tibia bearing. The female component can freely move on the polyethylene. It is a cementless fiber mesh. It is also innovative. So it is direct fusion between the prosthesis metal and the bone. And instrument is also sophisticated, so very accurate and easy to management. So in this generation, the instrument set is also focused on the past generation. Only the process is focused on, and the instrument is secondary. But now current implants is not only the prosthesis but also the instrument is very nice, very sophisticated, and very accurate, and very easy, and even the very small sized. This is the beginning of the very good instrument set, and this is a modular system, and the very compatibility is very good. That means we can prepare the small number of processes to prepare to the operation. So many compatible. Many parts are compatible. For example, this polyethylene can be used for the several sizes for both tibia and the femur side. This is more important. But this disadvantage is shortage is the patella is not good. because this patella is not all polyethylene. This is a metal box. And polyethylene was very thin. So sometimes after the wear of polyethylene in the patella prosthesis, the severe metallosis can occur. I several times I saw the severe metallosis along with the loosening of the prosthesis and the needs the revision. So after that, maybe the next generation media garant prosthesis, the particular prosthesis change to the all polyethylene. This one like this one. This is a mirror guarantee too. This is an improvement of mirror guarantee one. And the particular is changed to the dome type from the conform type. It is something like this. It can conform to the group of a patella in the femur component. And this is also we can use the cement type and total system to some augment system is the stem, extend the stem and augment or wedge shear. So that means this system can use for the revision or some kind of tumor. So we several times we use this component. It was really, really good. Then next generation is the next gen. So it's called the Mirror Guarantee 3. And we call it next gen. But in this generation, the previous generation, so processes is completely separate between the anatomical approach and the functional approach. So the mirror garant was anatomical approach, and the install Basten total control is functional approach. That had post and come mechanism. This concept was destroy the knee everything. That means the cut AC both ACL and PCL, and ignore the original joint line and joint kinematics, and destroy everything and regenerate the motion artificially to do by post and come mechanism or conformity of joint surface. Unlike this functional approach and temporal approach is to regenerate the original arterial surface. And conformity constraint is very low, so-called flat on flat, or on the femur and bearing articulation, or tibia and bearing articulation. So that can reduce the friction on constraint. And because if we retain the ligament, the movement on the kinematics of the knee is very, very limited, decided. Because for the knee, ligament and soft tissue is very important because this balance decides everything, the morphology and the kinematics. If we retain the soft tissue so much more, the shape and the motion we decided only one. If this is matched to these processes, everything is very good. But if it is different, so regenerate surface is quite different, and the motion was very different to the condition of the soft tissue, including the cruciate ligament. So the patient have some difficulty to movement, or limited ROM, and even the pain. So the anatomical approach So the process tends to have less constraint. In contrast, the functional approach destroys everything to cut the bone and cut the ligament, then to reconstruct the motion and the shape. And we call it a guided motion. So this, the shape of polyethylene and femur component surface and post-anatomical mechanics decides everything, decides their kinematics. This is, the kinematics is really different, completely different from the original one. But this processes aim to the similar kinematics before the operation and even before the disease. So this is the difference. But in this generation, after this generation, every processes have the both needs. Next day have CR knee and also has the PS knee. The next to the next gen is Persona. Persona also have CRG and PSG. So this is in this generation, in the modern implant system, has a total solution system. It has the both, not only the CR and the PSG, but also the reconstruction. For example, the stem augment. So this is the summary of the modern need. So it's has a sufficient long-term survival. This is due to the material, improvement of the material. For example, low wear rate polyethylene and very good shape of the both polyethylene and the female component. So we can use a different policy system, the both anatomical approach and the functional approach in the same system. So we can convert to another cutting policy in during the operation. For example, if I start for the CR, then eventually we damage the PCL and cut the PCL, then we can change to the PS. Or now we can change to convert to the CS knee, create the sacrificing knee. So roughly we can get the satisfactory result, satisfactory long-term survival, and the moderately satisfied patient satisfaction, but not perfect. So how to improve the patient satisfaction? It is very famous that around 10 or 20% are unsatisfactory after TKA. There are some reasons. The one reason is sacrificing ACL. After the ACL cut, the patient has the minor anterior instability or rotational instability. Maybe, of course, the prosthesis will help you to reduce this anterior instability due to the design of the shape of bearing and the femoral component, but it is not perfect. So what do we need more? So minimum invasion, because this TKA operation is very, very invasive. After the TKA patient has a very severe pain and severe swelling, so to minimize the invasion is very important. So UKA is the one solution to minimize the invasion and better adaptation. So for example, femur, AP, and M dimension. So it is only the decided size. Only the several sizes available for each prosthesis system. So to increase the type of the size of the component, we need to prepare so many number of processes in the same operation. So how to reduce the number of the prepared the processes? So pre-operative planning is very important, and better kinematics. So the currently, so we are focused on how to induce medial pivot motion along with posterior roll back motion. So it is quite easy to uh, generate, to induce the posterior roll back motion in the PSG because post and come mechanism can induce the rollback motion quite easily. But after the PSG, not only the lateral condyle but also the medial condyle will go roll back simultaneously during the knee flexion. It is not normal kinematics. So how to induce the medial pivot motion? One solution is retain both ACL and PCL. Another solution in the medial side is high conform type, just like the ball in socket. But lateral side makes flat articulation that can induce medial full motion. The medial side is stabilized and the lateral side can move freely and the longer durability. So better material on the both polyethylene this component. So achieve this. So one Japanese member tried to make this femur prosthesis using the ceramic. Another the way to achieve the longer durability is to vitamin E to combine the vitamin B into the bearing polyethylene. Okay, I will say the more detail about this material and this type of new type of knee in the next week. Okay. Okay. Thank you for coming. Thank you.